origin churches, a lot of the services are delivered through Latin, and a lot of the English words are from Latin. So triangulus in Latin means three-cornered. In the Greek language, and as I've told you before, the Greek language has had a big impact on mathematics and mathematical words. In the Greek language, triagonon, okay, triagonon means three-angled. Triagonon, I'm trying to get my Greek language perfected. Triagonon, okay, is to do with three-angled. So this is how special a triangle is. All triangles are convex. That means all of the sides, they point out, the corners go out. Okay, so there's no inward pointing vertices, and all of the interior angles in a triangle are strictly less than 180 degrees. So this evening, already, can you see what I've given you within about 10 to 15 minutes? Already, we know that a triangle is a very, very important special shape. It is a polygon with the fewest, the least possible number of sides. It's got 3 sides. And to bring it down to a young person's understanding, a triangle has got 3 sides, TRI. A tripod, the one where camera people put the camera on top, it's got 3 legs. Okay, I'm looking at a tripod at the moment now. A tricycle has got 3 wheels. So TRI, not TRY, but TRI, you link it with the number 3. A triangle, 3 straight sides, is a closed shape, 3 angles, and the 3 angles, the 3 interior angles, they sum. That means they add together to make 180 degrees. The sides of a triangle are called edges, and the corners, you've got 3 corners, they are called vertices. So you've got vertices, you've got edges, and this is allowing you to understand and to picture what a triangle looks like. I've now given you a mental picture so you can picture a 3-sided shape. All the sides, all the ends touch, so it is a closed shape. You can't get into the triangle. And the sides are straight, not curved, they are straight. And that's what makes a polygon a polygon. It's a 2D shape, 2 dimension. And 2D shapes are flat, and if you can fit it underneath the door, you know it's 2D. 3D shape, like a cube, you cannot fit underneath the door. So there's the difference between 2D and 3D. Really, really important. Okay, so you've now got a better understanding of what a triangle is, what it looks like, the purpose of a triangle, the use of a triangle, the origins of the word triangle, and you know about angles. There's the link between triangles and angles. I said earlier, if you look at the word triangle, you've got the word angle in the word triangle. 3 angles. This is what makes maths so magical and so exciting. Now, I've been working with some year 11s because at the moment now, we're in the exam season. And in a minute, I'm going to give some dates for your diary. A couple of students said to me, Mr. Numbervator, we're really, really anxious. We're really scared about our GCSEs, about our mocks, about our exams. And I said to them, I understand. I've been through it. I do understand. And it's almost like a rite of passage. We all go through it. We all do our maths exams when we're at school. What I then went on to say is, you know enough to pass. Have confidence in yourself. You can do it. And I made sure that my teaching gave them lots of confidence, encouragement, and support. They've all sat their mocks, and they all did really well. I believe every one of my students got 7 or above in their mocks. Now, if they're getting 7 or above in the mocks, they're on track for getting 8 or 9 in the real GCSE. And how did I do it? I did it by making my teaching direct, explicit, enjoyable. I made my teaching hands-on, which means they were doing, they were drawing, they were comparing, they were calculating, they were measuring, so that they could see the purpose of what I was teaching them. I wasn't just saying to them, we're going to do Pythagoras. I made Pythagoras come alive. Not literally the person Pythagoras, but the teachings of Pythagoras, I made it come alive. A little joke there. Anyway, so they enjoyed it. They enjoyed the physical side of learning maths. And this is what makes maths special. And this is what makes the maths show special, because I'm giving you real teaching, real focused, explicit teaching. I've got some dates for your diary. So I'm just going to have a little break in the show, because the show's about angles and triangles. I've explained to you what a triangle is. Just a little break, because people have been sending me messages and asking me about certain dates. So I'm going to read them out to you. So if you've got your pen, your pencil, or your paper, make a note of these dates. I'm sure you all know them, but just in case you don't, and mums and dads, parents and families, if you do not know the dates, then I'm giving them to you now. So Monday, May the 4th, the GCSE start. GCSE start May the 4th for year 11s. May the 11th, the following Monday, that's when the year 6 SAT starts. So the year 6 SAT starts on May the 11th. And then on June the 1st, that's when the year 4s are having their MTC, their multiplication tables check. Not test, it's a check. So let me give those dates again. May the 4th, GCSEs for year 11, they start. May the 11th, the SATs for year 6 starts. And June the 1st, the MTC, which stands for multiplication tables check, starts on June the 1st for year 4s. So we are entering the exam season. So I've seen lots of young people at the bus stop. They've got their books, they're revising, they're discussing. Whenever I go into a school, the library is packed, everyone's revising. There's lots of iPads, computers, everything is buzzing, lots of photocopying. And it's an exciting time of the year for exams, because everyone is focused and everyone wants to do well. You've been taught well in your school, because as I've always said, teachers teach very well in all of our schools, whether it's primary, secondary, college, tertiary, university. The teachers are teaching you very, very well. So make note of what they're doing. Get the benefit of having good teachers. So when it comes to your learning and your revision, you've had that introduction. It makes sense. Okay? So dates for your diary: May the 4th, GCSEs for year 11 start. May the 11th, the SATs. SAT stands for Standard Assessment Tests for year 6. They start. And on June the 1st, year 4, the MTC, multiplication tables test. That's when your checks start. Notice I use the word check and not test. Right, so back to today's show. So today's show I've called Angles and Triangles. So I've spoken about triangles. I now want to talk about different types of triangles. So I've spoken about what a triangle is, what it looks like, what makes a triangle a triangle. In other words, the properties of the triangle. We know that the angles in a triangle add up to 180 degrees. So I've given you a mental and visual picture of what a triangle is and what it looks like. Now, in schools, and when I say schools, I'm crossing from primary into secondary right up to year 11. In fact, A level and even degree level, you need to know about triangles. But there are four main triangles, that you need to know about, especially primary into secondary. There are four key triangles that you need to know about. You need to know their properties, what they look like, what makes that particular triangle a triangle, and how to use the triangle. So the first one I want to start off with, the first triangle, is what we call an equilateral triangle. Equilateral triangle. An equilateral triangle, as we know, has got three sides and it's got three angles. But what is special about an equilateral triangle is that each of the three angles are the same. They are the same size. Now, remember I said to you earlier, angles in a triangle, the sum of the angles equal 180 degrees. If you have got three angles and they are all the same size, you've got a bit of algebra coming. You've got a bit of an equation, because you can do 180 divided by 3 equals 60, or 60 plus 60 plus 60 equals 180 degrees, or 60 plus 60 is 120, 120 plus 60 is 180. So an equilateral triangle, not equilateral triangle, equilateral, EQUILATERAL. So if you think about the first 5 letters, they sound like equal, but it's equal, but it sounds like equal. That is telling you something about the triangle. So you've got 3 sides, they are exactly the same length, and you've got 3 angles and they are exactly the same size, and each of the 3 angles measures 60 degrees. That is what an equilateral triangle is. So you know what triangles look like. We've spoken about the sides are called edges, the corners are called vertices. There's a little song there. We know the uses of a triangle. Now we're breaking it down to different types, different names of triangles. And I've said that there are 4 that we teach you about from primary into secondary right up to year 11. Because year 11s do trigonometry, year 11s do Pythagoras, and we're using the right angle triangle. So you can see how purposeful and useful it is. So that's an equilateral triangle. My second triangle is one of my favorite sounding triangles. It's called an isosceles. Isosceles. I'm going to spell it for you. I-S-O-S, isos, I-S-O-S, excuse me, I-S-O-S-C-E-L-E-S. I-S-O-S-C-E-L-E-S. An isosceles triangle has got 2 sides that are equal and 2 angles that are equal. So 2 of the 3 sides are the same length and 2 of the 3 angles are the same size. So for example, you might have an isosceles triangle. One sloping side could be 10 centimeters, the other sloping side could be 10 centimeters, and the base of the triangle could be 12 centimeters, for example, or whatever. Okay, so 2 sides are the same, and then 2 angles. So one angle might be 70, another angle might be 70. 70 plus 70 is 140. So that means the third angle must be 40 degrees. So that is what we call an isosceles triangle. Two sides are the same length and two angles are the same size. Another one of my favorite triangles is called the scalene triangle. Now, once again, I used to find it really difficult to remember what a scaling triangle is and the name of it, until one day one of my teachers said, look in the fish tank. What do the fish have on their bodies? I said scale. She said, right, say scaling. And from that day I've never forgotten what a scaling triangle is, because I think of fish, and fish have scales. And when you spell scaling, the first five letters are SCALE, scale. I know you have weighing scale, but when you're young, fish are usually in the classroom in the fish tank, the goldfish. So a scaling triangle has no sides that are the same and no angles that are the same. So a scaling triangle, no sides are the same length and no angles are the same size either. So that is a scalene triangle. SCALENE. Scalene triangle. My fourth triangle is a right angled triangle. And a right angled triangle, one angle has to be 90 degrees, a right angle. Okay, like an L shape. The right angle, the letter L, right. That's what a right angled triangle is. So it's a 90-degree angle. And the right angle is opposite the sloping side, and the sloping diagonal line side is called the hypotenuse. So the right angle is opposite the hypotenuse, the diagonal, the sloping side. That's what the right angled triangle looks like. So what have you learned this afternoon? You've learned about what a triangle is. You know the origins of the word triangle, the Greek, the Latin, and so on. You know what the properties of a triangle. You know what a polygon is. You know what a 2D shape is. You know the uses of triangles in the real world, construction and architecture, music, navigation, flying, sailing. There is so much that you can learn from and about with triangles. It is brilliant. Okay, the triangle is a beautiful shape. Okay, so I've taught you about triangles, and what you're going to do next is we're going to have a short break, and when we come back after the break, we're going to be looking and finding out and learning about angles. What is an angle? How do we measure angles? What do we use to measure angles? What is the purpose of learning about angles? Different types of angles, drawing angles. It is going to be really powerful, and it's going to be a brilliant part 2 to the show. So get a glass of water, get a snack, whatever you need to do. 2 minutes, we're going to come back with a ruler, a pencil, a piece of paper, and we're going to be looking at angles. We've already looked at triangles, types of triangles, and we're going to finish off the math show with angles. It's going to be really exciting. See you shortly.
956. Go to www.sovereigncomics.co.uk and get your latest issue of Mr. Numbervator's Maths comic book series today. You are now tuned into the Mr. Numbervator show every Wednesday from 5:30 to 6:30 p.m. on Chalk Hill Community Radio Station. Let's get mathematical.
Hello and welcome back to part 2 of the Math Show with me, Mr. Numbervator, broadcasting live from Chalk Hill Community Radio Station. And at Chalk Hill Community Radio Station, we believe in keeping the community connected. Now, the community is not just our local community around the recording studio, it's the community at large. And what I believe in doing is keeping the community connected through mathematics, because we're using and doing maths 24 hours a day. Yeah, even when you're snoring, that is maths. Okay, everything is all to do with maths. So that is what I like to do. So every Wednesday between the hour of 5:30 and 6:30 is the Math Show with me, Mr. Numbervator, on Chalk Hill Community Radio Station. Now, before the ad break in part 1, I was just giving you some dates for your diary. I'm just going to give those dates again because a couple of people asked me just to go over the dates again because they weren't too sure. I'm going to go in reverse order this time. So starting on June the 1st, 2026, the year 4 pupils, they are the children in year 4 who are 8 and 9 years old. They will be taking their multiplication tables check, and we call it the MTC, to do with the times table. So it's the MTC, the multiplication tables check, and they start their checks on June the 1st. So when we say start, because there's a lot of year 4s in most schools, it takes time to actually administer and deliver. So it's not going to be done in one day. It's usually lasts the whole week. So that's when the year 4s. Now, May the 11th, Monday, May the 11th, the year 6 SAT starts. And the SATs means, and the SATs is Standard Assessment Tests. That's called the SATs, and they are for year 6. And they will be doing their English and their maths SATs in that week up to the Thursday. And then on May the 4th, that's when the GCSE exam starts for the year 11s. So June the 1st is for year 4s, May the 11th is for year 6, and May the 4th is for year 11. I went in reverse order because when I first gave the dates, I went the other way. So I think it's only fair if I mention the youngest first and the oldest last. So that's the exam season. So parents and families, adults, give our young people space, give them patience. Give them encouragement. Allow them to have plenty of sleep, plenty of rest. Let them relax. They can't have their head in a book all evening because it's what we call diminishing returns. After a certain time, whatever goes in is going to come straight out again because they won't remember it, they won't retain it. And so there's no point in doing it. I believe in short sessions on a regular basis. That becomes more meaningful. So, but you are the parent. I did it differently with my son. You're going to do it differently with yours. But this is my advice based on what I see. Okay? So short sessions, but more of them and regular, as opposed to one long 3-hour session. If I had a 3-hour session of revision, I would be asleep after the first 35 minutes, to be honest. It's just too long. And the brain can't handle it. And remember, adults, these are young people. They are young children. They are young people, 8 years old, up to 15 years old, 16. They are young people. Their brain is still forming. Okay? So don't put too much pressure on them. Allow them to breathe. Give them lots of encouragement, lots of love, lots of hugs. Make sure they sleep well, they eat well. And if you follow this advice, I'm telling you, you're going to see the results in August when all the results come out. Okay, but the year fours come out in July and the SATs come out in July, but the GCSEs come out in August. So that's the exam season. Let's get back to tonight's show. So tonight's show is angles and triangles. Earlier on in part one, I was speaking about different types of triangles, the names of different types of triangles, the properties of triangles. Now we're going to look at angles. So what is an angle? Well, to have an angle, you must have straight sides. That's the first thing. You can't have an angle with wobbly or curved sides. So imagine you've got two rulers and you join the two rulers together at the end. So it's like you've got a V shape. Yeah, you've got two rulers and you've joined them together at the end. You've got like a V shape. That space in between those two rulers, that is where the angle is. The angle is the amount of turn out of 360 degrees. That's what the angle is. It's a measure of the amount of turn out of 360 degrees. Now, how many degrees are there in a circle? 360 degrees. So imagine you've got a circle. Draw a circle. Picture a circle in your head and you draw a horizontal straight line right through the middle of that circle. You have split that circle into two equal parts. You've split that circle into two equal shapes, and they are semicircle. A semicircle is half a circle. So this is where maths becomes really exciting and interesting. Remember, a full circle has got 360 degrees. So because you've split that circle exactly in half, you can split it in half horizontally or vertically. Because you split it in half, each semicircle is 180 degrees. Because half of a circle is a semicircle, and half of 360 degrees is 180 degrees. So you've got a semicircle, okay? 360 divided by 2 is 180 degrees. Right, when we're teaching you about angles, we usually always start with what an angle is, what it looks like, where to find it. And I've said to you, two rulers, they connect at the bottom, the vertex, so it looks like a V shape. When you bring the arms together, the angle gets smaller. When you open up the arms become bigger. So as you bring the rulers towards each other, the angle is getting smaller. As you move the rulers away from each other, the angle gets bigger. But remember I said that they are joined together at the bottom like a V shape. That V shape, that corner, that vertex does not move. That corner, that vertex must be there. Then the corner must be there. that is what the angle is. Okay, right. Remember I said to you about the straight line through the middle of the circle, 180 degrees. That is one of our first rules with angles. Angles on a straight line always add up to 180 degrees. Angles on a straight line. Because remember, with that circle that you split in half, that is a straight line, isn't it? So the base of the semicircle is a straight line. And the angles on that straight line will always equal 180 degrees. Why? Because half of 360 is 180 degrees. So angles on a straight line always add up to what number? I can hear you all shouting. Yep, you're correct. It's 180 degrees. So let me give you a question. I'm going to make up a question live on my show this evening. You've got your straight horizontal line. I want you to draw a diagonal line that starts right on the straight line. There are no gaps between those two lines. Just draw a diagonal line. It can go towards the left or it can go towards the right. So you've got a horizontal line, and then you can find the middle of that horizontal line, and you can draw another diagonal line. It must be straight. The diagonal line can be going towards the left or it can go towards the right. Right. In between those two lines, there's a gap. That's the angle. Let's just say that angle that you have got there is 50 degrees. The other side of that line, of that diagonal line, that goes back towards the horizontal line, what must the size of that angle be? Because remember, angles on a straight line add up to 180 degrees. So if the small angle is 50 degrees, how big must the bigger angle be? Well, 180 subtract 50 is 130. So the other angle must be 130 degrees. Why? Because 130 plus 50 equals 180 degrees. And angles on a straight line always add up to 180 degrees. So already, if you were doing a GCSE, or you're doing an end of year 7, end of year 8, end of year 9, end of year 10, year 11 mock, that is worth 1 mark. Knowing and being able to calculate angles on a straight line is a 1 mark question. But how long did that take you? What, 20 seconds, if that? That's how good you are. And that's how exciting and magical maths is. Maths is not meant to be difficult. It becomes difficult when it is presented in the wrong way. And I'm going to say by the wrong person. You need someone who can bring some excitement, some passion, some individuality into the teaching. And when it's presented in a certain way, everyone gets maths. But this is the difference between Mr. Numbervator and maybe other teachers. It's about the passion, it's about the excitement, it's about the originality I'm bringing to my teaching and my delivery and my presentation and my engagement and my assessment. All of this just goes towards how a young person learns. And it's not just about learning at the moment, at that time. It's, can you remember? Can you then retrieve that information at another time, at another date? That's the important thing. And we call it, have you assimilated and accommodated the information? And this is what makes learning so exciting. So angles on a straight line always add up to 180 degrees. Why? Because half of the circle, when you use a horizontal line to split the circle into two, 180 at the top, 180 at the bottom, you've got a straight line. Remember, you can't have an angle with a wonky line. It's got to be a straight line. So that means the angles on that straight line total, they sum to 180 degrees. Right, my next one, angles around a point. I want you to put a dot in the, if you're using paper or book, just put a little dot in the middle of your page. Just put a little dot there. And then just do one line going to the left, one line going up diagonally to the left again, another one going straight, another one going to the right, and one going down. So you've got 1, 2, 3, 4, 5 lines, different directions, and you've got a point in the middle. Right. Each of those 5 angles, 1, 2, 3, 4, 5, each of those 5 angles will have a particular degree size. But the interesting thing and the fun thing is when you add up all of those angles, the total must be 360 degrees. So angles around a point. Remember I said to you, draw a dot. Angles around a dot, same thing, but in the textbook is angles around a point will always, must always add up to 360 degrees. So, for example, if one of my angles is 50 degrees, another one is 150, another one is 100, so that's 250, that's 300, another one is 10 degrees. The missing angle must be, well, let's have a look. 50 plus 150 is 200, 200 plus 100 is 300, 300 plus 10 is 310. So that means the other 5th angle must also be 50 degrees because 310 plus 50 adds up to 360 degrees. So angles around a point add up to 360 degrees. Hey, this is amazing. Okay, maths is truly amazing and it's easy. Okay, I'm sure you can add up 5 numbers. You write them in the column, biggest on top, smallest underneath. 150, 100, 50, 50, and 10. You add them all together, 360 degrees. Yes, you can use the calculator, but what about using your brain? What about using and developing your brain ability? That for me is really important and really special. Right, so we've looked at angles on a straight line, 180 degrees. We've looked at angles around the point. Let's look at opposite angles. So imagine you've got a horizontal line, and then you draw a diagonal line right through the middle of that horizontal line. So you've got a straight horizontal line, and then you've got a diagonal line that goes right through the middle of that line. You have got 2 angles, haven't you? And those angles are opposite each other. Yeah? 2 angles opposite each other. If one angle is 60 degrees, guess what? The other angle must also be 60 degrees. So opposite angles are always the same. Opposite. When you're sitting, if you're sitting on a train with your back to the window, so you're looking into the carriage, you've got someone sitting opposite you. They are facing you. They are directly opposite you. With angles, the angles that are directly opposite each other will always be the same. So if one angle is 60, the other one must be 60 as well. So what have we learned so far? Notice the way I'm teaching. I'm going back. I'm bringing you forwards. So angles on a straight line, 180 degrees. Why? Because the number of degrees in a circle is 360 degrees. If you split the circle in half with a horizontal line, it's 180 plus 180. So angles on a straight line, angles around a point, 360. Opposite angles are always the same. Then you've got what we call alternate angles. Now, alternate angles, I'm just going to give you a really easy, fun way to remember. Think of the letter Z. Now, they are not called Z angles, but when we think and talk and look at alternate angles, think of the letter Z. Because in the letter Z, you have got 2 angles, haven't you? You've got where the corners are, you've got 2 angles there. whatever the top angle is, the angle underneath will be exactly the same size. Whatever the angle at the bottom is, the angle at the top will be the same size. That is what we call alternate angles. So you think of the letter Z. And then finally, we've got what are called corresponding angles. And guess what letter of the alphabet you can associate with the corresponding angle? It's the letter F. It's going to be slanting a little bit, but you can still see the letter F there. And guess what? Those pairs of angles in matching corners will always be the same. Okay? So angles on a straight line, opposite angles, corresponding angles, alternate angles, angles around a point, angles in a circle, 360, angles in a triangle, 180, angles in a quadrilateral, 360. Now, listen, to finish off the show this evening, this is really exciting. Right, a quadrilateral, the word quad means four. If a lady gives birth to quads, she gives birth to 4 children. When you go to the beach or the seaside, you often see some of these flash young people riding about on the sand with bikes. And the bikes have got four wheels, and they are called quad bikes. They're meant to be on the sand. They're called quad bikes because it's 4. So a 4-sided shape belongs to the family of quads, quadrilaterals. A square is a quadrilateral. It's got 4 sides. A rectangle is a quadrilateral. It's got 4 sides. Any 4-sided shape is a quadrilateral. It might not look like a rectangle, but as long as it's got 4 sides, it is a quadrilateral. And angles in a quadrilateral always add up to 360 degrees. But let me explain to you the reason why. And this is why I'm excited about explaining. I'm going to draw a rectangle. I'm just going to draw a rectangle because it's got 4 sides. I'm just going to draw a rectangle. You draw a rectangle as well, yeah? And the corners are the vertices, the edges are the sides, and the corners are closed, so there's no space to get in, okay? Right, so I said to you that angles in a quadrilateral always add up to 360 degrees. Here's the reason why. Take your pencil or pen, go to the bottom right of your rectangle and draw a diagonal line to the top left of your triangle. So what have you done? You have split your rectangle into 2 equal right-angled triangles. Now, what did I say earlier about the degrees in any triangle? Degrees in any triangle will always add up to 180 degrees. So in one of your triangles inside of your quadrilateral, you can write 180 degrees. And in the other one, you can also write 180 degrees. And guess what? What does 180 plus 180 equal? 360. And that's the reason why angles in a quadrilateral add up to 360 degrees. Because whenever you draw a 4-sided shape, you will always be able to split that 4-sided shape into 2 triangles. 2 triangles. 180 plus 180 is 360 degrees. Now, at the beginning of my math show, I remember saying to you, I'm smiling because I'm doing what I love to do and I'm giving you the best. I'm making you the best. I want you to be better than me. If you can be better than me, I could have a nice retirement because it means that I've given you the best and then you will pass it on as you get older. Okay? We're coming to the end of the math show, but what I do know is that the math show tonight has been really, really exciting and valuable and meaningful. You've learned about triangles. You've learned about 4 different types of triangles. You've learned about angles, angles on a straight line, opposite angles are equal, corresponding angles, alternate angles, the letter Z, angles in a triangle, 180, angles in a quadrilateral, 360, and you know the reason why. Angles around a point, 360 degrees. This is Maths Coming Alive. And I'm making Maths Come Alive every Wednesday on the Maths Show, Chalk Hill Community Radio Station, with me, Mr. Numbervator. So, children, young people, parents, adults, carers, school teachers, inspectors, whoever you are, the exam season is upon us. Please give our children space. It can be really stressful, and we don't want our children to be stressed because they won't perform then. So make them know that whatever they do, whatever they get, you will be happy with it. Build up their confidence, build up their excitement, make them believe in themselves. And I can assure you, they will deliver the goods and they will impress you. It's been a great show again today. And you know me, I love the Math Show with Sovereign Comics and Mr. Numbervator on Chalk Hill Community Radio Station. Behind me is my banner, but if you go to sovereigncomics.co.uk, all the information is there about the comics that we make, about the courses that we offer, about the books and comics that we sell. All the information is on there. Give it a look. There's some exciting graphics and cartoons drawn by Dean, who's sitting opposite me. I was going to give him a little timetable test, but shall I do it? No, I won't do it. No. Anyway, but Dean's the one. Dean does that. That's what Dean does amazingly, brilliantly. Have a great evening. The sun is out. The sun is shining. I understand it's going to be a bit cooler at the weekend because this weekend we've got a bank holiday on Monday. So there's no school, but don't chair. Don't say yippee, because on that Monday, you have to be revising if you're in year 4, year 6, or year 11. Yeah. And if you're not in any of those year groups, you can still be learning. Okay. Learning, you never stop learning. I haven't stopped learning. Dean hasn't stopped learning. We never stop learning. Have a great evening. Thank you very much for listening. It's over and out. The Math Show with me, Mr. Numbervator, on Chalk Hill Community Radio Station, sponsored by Sovereign Comics. Have a great evening and see you next week. Thank you. Bye-bye.